Your lab standard in the respiratory unit asks you to have a working knowledge of the mechanism by which breathing is controlled, as well as the different respiratory volumes that make up your total lung capacity. The standard reads, I can explain how the breathing mechanism is controlled, including lung capacity. In the first video, we discussed the structures of the respiratory system. So we talked about your nasal cavity, your sinuses, your pharynx, your larynx, trachea, bronchi, and lungs. We also discussed the tiny microscopic air sacs known as alveoli, across which gases like carbon dioxide and oxygen can easily be diffused. In this standard, LUNG.3, covering the breathing mechanism, we're talking about breathing as a comprehensive cycle of inspiration and expiration. Those are fancy ways of saying inhalation and exhalation. So one combination of those two is a breath. When you're at rest, the pressure of the atmosphere, which of course is dependent on where you are regarding sea level, but the atmospheric pressure, let's say an average of 760 millimeters of mercury, is equal to the pressure inside your lungs, your alveolar pressure. So we see nothing moving. If the pressure in the air, which is forcing its way into your body, is equal to the pressure in your lungs. If it's 760 and 760, we are at rest. Atmospheric pressure equals alveolar pressure. When we want to inhale, though, we have to create a difference in pressure. That's what will cause the diffusion to occur. That's what will cause air to rush into all the tiny little air sacs, all those alveoli. So in inspiration, the way we do that is by contracting our diaphragm downwards. So in your abdominal cavity, you have a thin muscular sheet that separates the abdominal from the thoracic. It's right inferior to your lungs, so it's right underneath it. And it's one of the few muscles that either runs on autopilot, you don't need to control it, but you also can jump in the pilot seat and control it. You can inhale and exhale quickly, but you also can sleep all night and continue breathing. So when you need to inspire, when you need to inhale, the diaphragm contracts downward. Now we need to recall some chemistry. Boyle's law says that as volume increases, pressure will decrease. So we're moving the diaphragm downward, and that's ultimately creating a bigger volume of space here in the lungs. As that volume goes up, the pressure in the lungs is going down. Notice it went down a little bit, 758 millimeters of mercury instead of 760. Very small, but it's enough that the atmospheric pressure is now greater than the alveolar pressure. Therefore, air will rush into the lungs. When you want to take a deeper breath than this, it's going to take extra muscles to expand even further. So for instance, these muscles in between your ribs, the intercostal muscles, deep breaths require contractions of those to form an even greater difference in pressure. When you want to breathe out, it doesn't take effort. That's more of a relaxation process. So expiration involves elastic recoil. All the lung tissues, the diaphragm, maybe the intercostals, they all snap back into their original shape. As the diaphragm relaxes upward, that will cause the volume in the lungs to decrease, therefore causing the pressure to increase. And now we flip that script. Now the atmospheric pressure is less than the alveolar pressure, leading air to be forced out of the lungs. Like I mentioned, resting expiration is passive, but you can express more air than that. You can force extra exhale to get every last drop out. Not really, but more than usual. And that is active. That does require tension in your muscles. The other piece of this standard is respiratory volume. So what are the names for the different types of breaths that we can inhale and exhale? I've used this color-coded graph and I've color-coded my fonts to correspond. So a normal breath, the amount of breath in and out, is called the tidal volume. Notice that it's right here in the middle of your graph. It's less than 1,000 milliliters of air, but even before you take a normal inhale, exhale, you have air in your lungs, and you could take a way deeper breath, but you don't. So tidal volume is normal. We're usually sitting here. If we wanted to, this is supposed to represent yellow, we could inhale, exhale, and then force more air out. That extra air that's sitting in there that you can force out if you really want to is called your expiratory reserve. Even underneath that, you still have air in your lungs because you're not flat. We would have to roll you out with a steamroller to get the residual volume out of your lungs. Simply because they're inflated and not collapsed, you have about 1,200 milliliters of residual volume. We haven't really covered when you take a super deep inhale, and so that's included in your vital capacity. This big double-ended arrow right here represents vital capacity. So that's the max volume of air that you can inhale and then exhale as much as you can, still not counting that residual volume. So this is vital capacity. When we're talking about all of it, your max inhale, your tidal volume, your expiratory reserve, and your residual volume, that is total lung capacity. And in an average adult, it's between 5,000 and 6,000 milliliters, though you can be larger or smaller depending on your body size.